So if you have been, I can't unsee that. If you have been, if you've been following along the video before this, hopefully you had a chance to find the volume. To find the volume of regions revolved around an axis or a line. And every one that we did on the last video, the last link, they did not have any spaces. Okay? So in this case, it's going to be a little bit different because if you notice, there is going to be a gap between this area and the line that we're revolving around. So here's another example we'll do in a second. So see, there's a little gap here. And the last one we're going to do has a little space here. So what happens is it creates a washer. All right, so Georgie actually already kind of figured this out last week. She said, so to do it, you just need to find, essentially, we're going to imagine that the shape doesn't have a hole in it. So find the area of that. Then find the area of the hole that makes it a washer, and then subtract it. Okay? So that's all we're going to do. So what I need you guys to know for calculus is that eventually, if we can find the area, how do we find the volume? How do we go from area to volume? How have we been doing that last week? Not the other way. Which another word for that is an integral. So if we integrate the area, so I always think integrate the area, and that will allow us to find the volume. All right, so that's what we're going to do here today. So the idea is if we can find a capital R, which I'm calling to be the distance from your axis of revolution to the farthest function, all right, find that radius. Then if we can find lowercase r, which is the distance of your axis of revolution to the closest function, right? Those will give us the radiuses, or I should say the radii, to find the area, and then we'll integrate that to find the volume. Okay? So in this case, what is my line that I'm revolving around? 10. Y equals 10. For the first one, y equals 10. All right, so I'm going to do 10 minus, and what is my function that is farthest away from y equals 10? Bless you. So there's two options. It's either 2x squared or 4x. Make sure you're focusing on the functions. And what you should notice is that it is the parabola. Do you see how that's the farther one is the parabola? So I'm going to write 10 minus 2x squared. Okay? Now, if I do the same thing for the closer one, that's my lowercase r, that's 10 minus, and which function is closer to that axis of revolution? The line, right? The linear function. So 4x. So I'll pause here. Is everyone okay? That's kind of like the setup part in terms of determining the radii. Okay?
It's not like without that. Like on the.
How do I know that that's the closer one?
Yeah.
Because the line is closer to the axis of revolution as opposed to the curve. David's got it. Okay. So to find the area, and you don't have to write this down if you don't want to. Just kind of show you kind of more work than you need. But if you find the area here, we would find the area as pi. Notice I wrote the big R squared because that's like if the shape didn't have a hole in it. Then if I do pi times the little r squared, this is the area of the part that makes it a washer, the whole part. And if I subtract that, that's going to give me the area of that shape. But remember, do I want area? No, I want the volume. So I'm going to do the integral of this. So here's the setup. Do you see how they kind of share pi? Pi is in the first one and it's in the second one. All right, and you should know that pi is A constant. Yes, it's that, but it's a constant. So where do I put constants? In front of the integral. So that's kind of the first setup. This one actually gives you the limits of integration. If you look here, this is x equals 0. And what is that x point there where they intersect? 2. Very good. So 0 to 2. And then I'm literally just going to put in all of that area. Okay? I'm just going to put in that area formula. Obviously, don't write pi anymore because you've already put pi into the front of the integral. Okay? So I'm going to do 10 minus 2x squared. Okay? Now make sure, what should I do with that radius? Square it. And then minus 10 minus 4x. Again, that's another radius. What should I do with that? Square that. And then don't forget the notation. What should go at the end? dx. Thank you, Julia. Okay, this is it. Now I'm going to go to my calculator to figure out what the answer is. Everybody okay? Is it? We get to use the calculator now. Okay, now just to let you know, if you're watching the video later or if you're listening right now, you guys know that I like to do brackets, right? But Desmos does not like brackets for this. All right, so when you're using Desmos, use another set of parentheses. Okay, don't use brackets for this. Use another set of parentheses. Robert, Anna's trying to talk to you. Are you okay back there? All right. So just so you know how to do this, I know some of you don't have your Chromebooks out. That's okay. I can help you with it. But how do you know how to get pi? Do you know what to type in to get pi? Yeah. There you go. Do you know what to type in to get the integral symbol? INT. Yep, int. So pi int will get you that. 0 to 2. Was it 2x squared, I think?
Squared minus 10 minus 4x squared. Yes.
All right, so this is the volume. This is the volume for this three-dimensional shape. Okay? That's the answer. 113 point. Let me see what it wants me to round to. Correct. Nearest thousands. So I'm going to do the 0 after the 5 is going to keep it as 0.935. What's up? It's best not to lie.
Rounding is hard.
Rounding is hard? I know. 4th grade math can be tough. Okay. Put your pen or pencil down. My guys, it's going to take, let's use appropriate words. It's going to take a long time if we can't be quiet. Okay, pencils down. We're all looking at the screen. We're looking at the screen. That one. I want you to look up there. Thank you. All right, so watch what this looks like, okay? Just watch what it looks like. I don't need you to judge me. Okay, see how that is the problem? You see how that's the problem we just had? That's not the moment yet, but a little early on the well. Okay? This is what we just did. Okay. All right, guys watching? Yes. So this is what we had. And then if we revolve that around that axis, this is the shape that's made, and you can see the volume begin.
Dang, wait, so if it's touching the axis of revolution, it would be like a closed wall.
Correct. It's not. This is called a washer because it has like that circular shape in the middle is open, like a washer. We call it a disc if it doesn't have that space. Well, no, you can assume that these are closed. That's okay. But I'm talking about like the hole, like. Correct. All right, let's go number 2. Pick up your pen or pencil. Okay, let's go number 2. I just want to show you that so you can see what it looked like. Okay, you'll get to that page as well once you submit an answer. Ready? Okay, number 2, pick up your pen. All right, here we go. We are revolving this area between an exponential function with e to the power of x plus 1, and we also have y equals -1. We're revolving it around y equals -4. So when I figure out my capital R and my lowercase r, I'm going to be doing -4 minus something. So -4 minus something. So remember, the capital R is for the function that is farthest away from the axis of revolution. So which of these functions is farthest away from the axis of revolution? E to the power of x plus 1. So I'm going to subtract that whole function. Notice my parentheses there to make sure that I subtract both pieces. Okay? Go to the other one. It's going to be -4 minus, and what is my other function? Be careful here. It's minus -1, right? Y equals -1. So just be careful there if you want to clean it up. All right, when I do this subtraction, I get the opposite of e to the power of x. What is -4 minus 1? -5.
What is E again?
E is the natural exponential function, so it's approximately 2.7183. Okay, then if you do -4, it's also the base of your natural logs. If you do -4 minus a -1, that's going to become -3. All right, let's do the setup. What goes first? Pi, thanks for that, the first one. Now this one again gives you the limits of integration, right? It says from 0 to 2, right? X equals 0 to x equals 2. Let's do our uppercase radius squared minus the lowercase radius squared dx. Don't forget to use another set of parentheses instead of brackets when you use Desmos to do it. All right, let's type it in.
You got this?
I have not tried to graph it with this in Desmos. I'm sure you could. All right. So let's do pi int 0 to 2. We have, I believe it was the opposite of e to the power of x. I forgot, was it -5? -5, okay. And then minus -3 squared. So the volume for this shape is 385.441. So Alan, you asked about rounding. Notice the 8, boys. Notice the 8 after the hundredths place, the thousandths place 0. The 8 there is going to make that 0.441. Do you have a question? Who's calling you? Oh, just ignore the haters. Okay, let's do number 3. Let's do number 3. All right, so number 3, make sure you flip it over to number 3. Last one, and then you guys are going to try. Okay, what is the line that we're revolving around? Y equals 5. So I'm going to do 5 minus 5 minus, and which function is farthest away from that line? Actually, the line is farthest away, right? If I look at this area, this line is farther away from this axis of revolution. Okay, so I'm going to do 5 minus 1/3 x minus 1. That's going to be my capital R. So remember, that's the axis of revolution minus the farthest one away. The one that's closer is going to be the natural log of x. All right, let's clean up the uppercase R. What is 5 minus a negative 1?
4.
No.
Negative.
No. It's 6. Nope, just 6. Thank you for that. I'm not going to do anything to my lowercase 1 since it's just the natural log of x. Okay, here's my setup. What are my limits of integration? Let's see. Looks like they are touching here and here. Can you just estimate? No. Good thing we're using a graphing calculator.
Wait, what if I think they're touching it?
Well, you're going to find out that what you're thinking is incorrect. All right, one of them was the natural log of x, right? And the other one was 1/3 x minus 1. I'll show you, Anita, don't worry. Like the ones that you have on the AP exam will give you a figure, or they will expect you to be able to solve them. They're not expecting you to solve it natural. Don't worry, we're gonna practice. I promise. Okay, so do you see the x values? Come on, Alan. I know you're not asleep. The x values are, I think somebody said about 0.5. It's 0.424. It's not right. That's just math. And then the other x value is 9.868. So Georgie, when you said 10, I mean you're close, but you were incorrect. All right, then I'm going to do my capital R squared, so negative 1/3 x plus 6 squared. Yes, Kyle, what's up?
So, say we have will we have one of these questions on the
Yes, so what I told Anita was either it'll be, we're going to practice many of those. You'll be expected to set each of these functions equal to each other to figure out where their intersection points are, or they will give you a sketch of the graph. And you'll be able to see from that sketch where they intersect, right? What they usually like to do with these is to give you a linear one and a quadratic one, and then you end up having to solve a quadratic equation with factoring, right? So as I've told David many times, it's the algebra that'll get you, not the calculus. All right, let's plug it in.
We have to do this by hand on the test, right?
Correct, yes. There will be some that will be with calculator. We're going to go over that after Easter. So 0.484, was that right? 0.424, closer. It is, but I'm okay with this. It's going to still give you the right answer. So I get 175.294.
Oh, and
Okay.